Hi y'all. In this module, what we're going to do is we're going to simplify some radical expressions, but now we're going to work with variables. So again, to simplify, we have to understand what makes a variable a perfect square and what makes a variable a perfect cube. So if you recall, we've already discussed this. If a variable is a perfect square, it will have an even exponent. So for example, if I have the square root of 8 to the 12th, because that exponent 12 is even, we know that that's a perfect square, which means we can square root it. And the square root of 8 to the 12th is 8 to the 6th. Because if you recall, what we do to square root a variable is we divide that exponent by 2. If a variable is a perfect cube, its exponent should be a multiple of 3. 3, 6, 9, 12, etc. So again, if you look at my expression, I have now the cube root of 8 to the 12th. Well, that exponent 12 is a multiple of 3. And the cube root of 8 to the 12th then would be 8 to the 4th. And the shortcut we did there is when we do a cube root of a variable, we divide our exponent by 3. Okay? Now, what's going to happen in this module is what happens if we get an exponent that isn't divisible by 2 or 3? How do we do the square root or cube root of a variable that's not a perfect square or a variable that's not a perfect cube? That's our goal. So let's look at our next expression. I have the expression square root x to the 5th. Okay? If everybody thinks about it, we're doing a square root. To do a square root, you have to have a perfect square. X to the 5th is not a perfect square because your exponent's odd. So one way to do this is to think in your head, how can I rewrite x to the 5th as factors that have a perfect square? So in other words, what would be the biggest even exponent in x to the 5th? And you all have to agree the biggest exponent that's even in x to the 5th would be x to the 4th. So I could rewrite the square root of x to the 5th as the square root of x to the 4th times x. Everybody agree with that? X to the 4th times x would be x to the 5th. X to the 4th of 4 would be the biggest even number in 5. You all agree? Now we could square root it. The square root of x to the 4th is x squared. Can you square root the letter x? Well, no. Because if you just have the letter x, it's understood to have an exponent of 1. And to square root, you need a group of 2. So we would leave that x inside the radical sign. So the square root of x to the 5th simplified is x squared times the square root of x. Now, another way to think about doing this is real simple, is to do that whole concept of dividing. Our original exponent is 5, and the square root, you're dividing it by 2. How many groups of 2 can you get out of 5? Well, let's think. Third grade math. 5 divided by 2 is 2 with a remainder of 1, correct? So what that's showing you is that when 5 divides by 2 and gets 2, that 2 is the exponent on the x on the outside, because that's the part you square rooted. That remainder 1 is the exponent on the x that's still in the radical on the inside, in the radicand, because that's what was left over that didn't have a buddy. Now, the same thing works with cube roots. We know with cube roots, your exponent should be a multiple of 3. Well, if you look at my last expression, I want to do the cube root of y to the 11th. Well, is 11 a multiple of 3? 3, 6, 9, nope, it's not. 3, 6, 9, 12, nope. So again, the rule is you can think of it as 2 ways. You can think of it as what's the biggest exponent that's a multiple of 3 and 11, which would be 9. So you could rewrite y to the 11th as y to the 9th times y squared. Everybody agree with that? Because 9 is the biggest multiple of 3 in 11, now we can cube root it. The cube root of y to the 9th is y cubed. Can you cube root y squared? No, because y squared only has 2 y's, and to do a cube root, you need a group of 3. So that's why the y squared stays inside the radical symbol. Another way to think about this is the whole division. If you have a cube root of y to the 11th, all you need to do is take the 11 and divide it by 3. Well, 11 divided by 3 is 3 remainder 2. That 3 is the exponent on the variable that's outside the radical symbol. So that's why outside the symbol we have a y cubed. That 2, that remainder 2, is the exponent inside on the variable that's the radicand. So that's why inside the radical symbol we have a y squared. All right, let's go to the whiteboard. Let's practice more of this.